Hey y'all, this is Mr. H speaking, just saying, hey, what's up? And doing this video is all about your Algebra 1 midterms review. Now, again, you're being tested on the things that we did in class and going to do in class. So, that's what this is for. And of course, I will touch a lot of additional practice that you can get so you could be master at this when it comes to the test, all right? So let's go ahead and get started. So what you must know for the test, solve its various linear equations, which we did that. Scientific notation. That was one of you guys that we missed, but we could talk about that. Exponential laws, which we all did in class. Identify types of functions, which we would do next in class, and polynomials. I am making this test very easy. All right. So if you did the homework, you paid attention in class how things are done. If you did the practice, you're gonna be all right. So let's go ahead and do this. Operations of polynomials. Now, to do this on your test, it's gonna be real simple. So I'm gonna do the proper first to the left, obviously. So to do this, you're gonna pretty much get your like terms for x squared. Get your like terms. When you do it like this is going to help you keep up and make things easier for yourself. All right. See how I put how it's color coded? Now with color coded, make it easier for you. 4x squared plus 2x squared plus x plus 3x plus 7 plus y. Now, so we did all that in those colors. Let's put everything together like terms. 4x squared plus 2x squared. That's just 6x. Sorry, I'm gonna do all that in black. 6x squared. All right, x plus 3x. That's essentially 4x. 7 plus 1. That's just 8. Boom. And that's your final answer to deal with the problem to the left. Simple, no? So let's deal with the complex one to the right. So let's do it. Now we're doing the problem to the right. We already did the problem to the left. So I'm scratching down so you guys know where I'm at. So let's do this guy. So before you can combine anything, you got some distributing to do. Distribute here. So because 6 is positive, just distribute. And then there's negative side, distribute here and distribute there. So distributive properties is just a way of saying multiply the whole thing by what's in the outside of the parentheses. So 6 times x is 6x, right? So what about 6 times negative 8? Well, that's just a negative 48. Let me rewrite all this to the center. So we got 3x plus y, and then we got plus 6x minus 48. And then when we distribute it again, we get negative x minus 2. That's what you get. So now we did all of that. Let's combine our terms. And again, the 6x minus 48 come from the distributive property of 6 times x and 6 times negative 8. And then the negative x minus 2, I want you to see, because I distributed. So negative x, which is understood to be negative 1, times x is just simple negative x, and negative 1 times 2 gives you negative 2. So that's where I got all that from. So let's combine our terms. 3x plus 6x, and that's 9x. Minus x, which is minus 1, is 8x. So again, I'm getting all my like terms. And you want to get the coefficients, so 3 plus 6, which is 9, but minus 1 gives me 8. So, let's do the other one with all of the coefficients. So I got 1 minus 48, which is a negative 47, minus a negative 2, that's a negative 49. And that's your answer to that one. All right, solving various equations. So look, again, I'm gonna see to it that you guys have additional practice of different styles of problems. So you will have that to practice and study. Cause look, I need for you guys to have it together on all of this. All right. So let's go ahead and do this. So look, you got x minus 16 over 4 equals 5. So unfortunately, I know for a fact many of you guys want to do something with that negative 16 and move it to both sides. You cannot do that because it's part of the division problem, x minus 16 over 4. And you have to get rid of that division problem. So going back to your early days of elementary, you know for a fact to get rid of a fraction of any sorts, all thing you gotta do is take its reciprocal. So the reciprocal of this, or the multiplicative inverse from what was taught to you guys doing in 7th grade, is going to be just n. Because look, n is pretty much n over 1. So every number can be written as a fraction over 1. For example, if I was to say 5, well, I could write that it's the same as saying 5 over 1. But if I was to take the multiplicative inverse or the reciprocal, that's going to be 1/5. That's what you have to do. Because remember, all algebra is doing is undoing everything. To get x by itself. Undoing. So let's go ahead and undo all of this. So again, we know for a fact that a fraction is written as division. So we know that a fraction is division. So what's the opposite of division? Multiplication. So therefore, to get rid of it, you're going to multiply by 4. And again, going back to equations, what you do to one side, you do to another side, do to the other. So we multiply that, let's get rid of that. 4. So 5 times 4 is 20, right? So you get x minus 16 equals 20. And to solve that problem, now it's easy. Take the additive inverse of negative 16, make it positive, and what you do to one side, you do to another. So 20 plus 16, x equals 36. That's what you got to deal with. All right? All right, this is another style of equation. My work to do, huh? But we could do it. So, as I told you, use distributive property. Use your distributive property for everything. Because anytime you see a number outside of the parentheses, you always want to do this thing called distributive property. So, negative 5 times 1. I'm starting over here. Let me highlight so you guys know what over here is. I'm over here. That's where I'm at. So let's do this. Negative 5 times 1. Negative 5. Negative 5 times a negative 5x. That's going to be a positive 25x. Alright? So, now I'm over here. So guys, 5 times negative 8 is what? Negative 40. But don't forget you have the x with that 8, so you got to keep it like that. 5 times negative 2 is what? Negative 10. Okay, so let's pause for a second because something that Miss Howard forgot to remove. No, Miss Howard got it right. The thing that I was addressing is this negative 5, this 5 right here. 5 times negative 8 does give you a negative 40. All right. Equals negative 4x minus 8x. So we did that part. Now, let us get ready to combine our terms. So you gotta deal with things that are alike on both sides. So let me do what's on the right hand side of this. I want the right because that's easy. So look, I got negative 4x, negative 8x. When I combine them together, I get negative 12x. Again, you're not multiplying, because when you multiply two negatives, you end up with a positive. So, all right. Let's now do the left hand side. Again, you want to get your like terms, things that they have in common. So this 25x and this negative 40x. All right. So 25 minus 40. I'm gonna end up with a negative 15x. So a negative 5 minus 10. And let me show you what I mean. So I'm over here now. Let me change the color so you guys can really see what I'm doing. I'm over here. So negative 5 minus 10 is negative 15. All right, we almost there. So remember, your job is to get x by itself. To do that, you have to move one of those x's. I know you guys want to say, let's move to the right hand, let's move the right hand to the left. You can't do that because when you do, you get 0 here, and that's not going to work. So let's get to negative 15, and let's add a positive 15 to that. So what we do to one side, we do to the other. All right, so negative 12 plus 15, that's 3x. Negative 15. So x equals negative 15. Hold up, let me pause that for a second because I need for you guys to understand that next step. So be very careful about it. So guys, to get x, you got to divide by 3. So x equals negative 15 divided by a positive 3 is a negative 5. And that's it. That is how you solve that complex problem. All right. So let's move on. All right. So you guys, the last thing that we will talk about that will be on your test is talking about the relationship of functions. Well, not the relationship of functions. You have to identify the type of functions. So you guys should know by now a function that you guys have been dealing with is a relationship between two situations. For example, if you want to talk about boyfriend girlfriend, that's an example of a relationship, obviously. Teacher and student, it's a good one too. Parent and child is another one. Because look, in a situation, in those relationship, you're going to have one that depends. One's going to be independent, meaning that this person is not in need of anything. For example, let's talk about school. So with school, when we talk about student and teacher, and we talk about getting an education, getting it, the student is why, because the student depends on the teacher to get the education, and X is independent, meaning that the teacher is not, don't have to be the teacher, you know. Or you could switch around and say teacher's the X, the y. Teacher depends on the student. And of course, in my classroom, that's not the case. But you get the point. But know this, with the function being the relation of mainly two items or two situations, one's going to be dependent, one's going to be independent. And that's just how life works. So let's erase all this and let's go ahead and get further in this. Identify the type of functions. Let it be linear, quadratic, or exponential. So guys, to tell this, just look at the relationship of it. So let's look at x. So what can we say 2, 3, 4, 5, 6? What pattern do you notice? Well, in terms of the x, I'm going all by 1. All going by positive 1 plus 1. All right. So let's look at the y side, the dependent side. So we got -7, -15, -23, -31, and 39. So let's look at the relationship between these. So 39, and the best way to do that, I'm sorry, you guys, you're going to have to subtract to find that common difference between the two. So let's use 39. So don't pay attention to the negative signs for the moment. Just for the moment. So 39 minus 31, that's 8. That's the difference between these two. You could say, oh, it decreased by 8. So let's look at 31 to 23. As my negative numbers shrink, I keep increasing by 8. So negative 23 to negative 15. Well, I'm still increasing by 8 on this. So negative 15 for 7. I'm increasing by 8. Notice that when I go back and compare those numbers to find the common difference is 8. In every last one of them, all of them for the y side or the dependent side is all 8. So therefore that function is linear. And again, a function is a relationship of two situations. And we will discuss this further in class if we need to. But for testing purposes, you just learn how to do that to identify that as a linear function. All right, guys, this particular function that you're dealing with is dealing with a quadratic function. So let's go ahead and talk about it. A quadratic function. What do we do to do this particular situation? I'm getting blown up today. Sorry. So let's move on. So guys, when you're dealing with these tables, please be aware that you don't have to really worry about your x's or whatnot, because you know that all the cases they give you one. The difference between these two numbers, 7 minus 6, that's 1. The difference between 6 minus 5, of course they're negative numbers, so negative 6 and negative 1, 5, that's 1. So negative 4 and 3, that's also 1. So the whole relationship on the x side is 1. But what you need to be worried about to determine if they linear, quadratic, exponential is what's going on with the y, the dependent side. So to do that, of course, what's the difference of
112 and 63, if I'm trying to figure out those differences. Well, I know the difference between those two is 49. So from 112 to 75, I know the difference of that is going to be, doing the numbers in my head as I check them with the calculator, is 63. Alright? So let's move on. So what's the difference of 175 and 252? 77. Alright? So what's the difference of 252 and 343? And when I mean by difference, I mean subtracting. So for those who did cut on to that, 91, the difference is 91. So look, there's no pattern with that, right? So guess what you have to do? You got to do that again. So you're going to take these numbers and you're going to find the difference between these four numbers. So guys, difference means to subtract. So 91 minus 77, the difference between those two is 14. So what about 77 and 63? You get 14 again. So what about from 63 minus 49? Oh, I get 14 again. Because you have to do this twice to get a pattern. To find a pattern, you have to do that twice. Therefore, it's a quadratic function. A quadratic function is dealing with the x with the exponent of 2. So, again, the reason why we talk about that is because part of Eureka and for what you was taught or should have been taught is to identify these situations. So let's move on. All right. So this table tells me that this is a exponential function. Of course, the independent sign is not to be worried about it. You don't have to worry about either of that because we know for a fact all that is going to be increased by 1 or a difference between 1. So here, we could look at these numbers. My friend, let's try the way that we have so you can see what happens. So guys, 240, 243 minus 81. The difference between that is 162. So 81 for 27. Difference of that is 54. What about 27 for 9? Well, if I find the difference of that, I get 18. So 9. So I get the difference of 6. So look at that. You know for a fact that's no parent going on. So let's try again and see what happened. So 162 minus 54. The difference between those two are 108. So I go 54 If I find the difference from 54 and 18, I get 36. And then if I go from 18 to 6, I get the difference is 12. Well, that's a problem because guess what? You did this twice, and there's still no clear-cut pattern. So as a result, when you do this, when you try to find the pattern of this y, and you did it 2 times and no pattern, and what I mean by pattern, I mean difference, a pattern of differences. This is going to be exponential. But let's take it a little bit step further. So we realize, okay, the difference between all those y numbers, there's no common difference or a pattern. So I tried it again, and there's still none. So Mr. Howard, you tripping? Why are you giving us this for? Well, because you got to know it. So look, so you can understand the why in terms of these things. Look at these numbers. It starts out real small, but you notice that it doubled, because 3 times 3 is 9. And then it's triple. 2 times 3 is 27. It just keep getting bigger, bigger. But have you heard the term exponential? Like, the city of Baton Rouge has grown 51% exponentially. That's just said that it grew rapidly. It got bigger fast. So look at it. So I went from 3 to 9, 9 to 27, 27 to 81. And again, I know all those are negative numbers. So to ask a question to find the difference of these things, the negative numbers are not going to matter. Because at the end of the day, you're going to still get the same difference. Right? So let's go ahead and move on. And again, with this, find an exponential function of a table or to identify as an exponential function given the table. You know when you try to find a pattern twice, there was a distinct pattern. However, get back to what I was talking about before I could move on. So I went from 3 to 9, I doubled. And then I went from 9 to 27, I tripled. And then from 27 to 81, I quadrupled. And then from 81 to 243, I uh, just exploded, exploded 5 times. So that's how you can tell. So again, if you do this pattern twice and you don't get nothing, that means that you're down to an exponential function. Exponential laws. So let's do it. So remember I told you whatever was in the parentheses, you just distribute it. So 2 times 0 is what? 0. So x to the 0 power is just going to be 1. So guys, x times 3, x times, x to the q power times x squared. That's just x to the 6th power. So how can I rewrite this? I could rewrite this as x to the negative 6th power. Oh, Miss Howard was chirping. Don't fall for this mistake. What mistake did Mr. Howard make? See, can y'all call it out? Well, the mistake that was being made is that I couldn't multiply those exponents in the denominator because when you got the same base multiplied together, those bases gotta be added. So 3 plus 2 is 5. So that means my power gotta be 5. I could rewrite that as x to the negative fifth power. Essentially, do just that. So these are the kind of things that you will see on your exam. So just please watch the video, please study it, and you should be good to go. All right, y'all.